This session will introduce you about the models of columns and pressure changers. Columns model category contains the unit operation models for distillation columns using shortcut and rigorous calculations, and also for the liquid-liquid extraction as follows. The first model is the STWU. The STWU is a shortcut distillation design using Wynne-Underwood-Gilliland method for a single feed and two products distillation column with a partial or total condenser. For the specified recovery of the light and heavy key components, the STWU estimates either minimum refrac ratio or minimum number of theoretical stages. The STWU also estimates one of the following requirements. It determines the actual refrac ratio when the number of theoretical stages is given, or determine the actual number of theoretical stages when the refrac ratio is given. The STWU also estimates an optimum feed stage location and also condenser and reboiler duties. The second model is the ISTL. The ISTL is a shortcut multi-component distillation rating model. This model uses the admixture approach to separate an inlet stream into two products. You must specify a number of theoretical stages, refrac ratio, and overhead product rate. Then the DISTL will estimate the condenser and reboiler duties. The next model is Radfrac. Radfrac is a rigorous model for simulating all types of multi-stage vapor-liquid fractionation operations. In addition to ordinary distillation, it can simulate absorption, reboiled absorption, stripping, reboiled stripping, reactive distillation, extractive and azeotropic distillation. There are two modes in Radfrac. In the rating mode, you need to specify column parameters such as refrac ratio, product rates, and heat duties. Then the Radfrac will calculate temperature, flow rates, and mole fraction profiles. In the design mode, you need to specify temperature, flow rates, purities, or recoveries. Then the Radfrac will calculate column parameters. Radfrac has extensive capabilities for sizing and rating trays and packings. You can choose from several common tray types and random and structural packings. The next model is Extract. Extract is a rigorous model for simulating counter-current extraction of a liquid with a solvent or liquid-liquid extractors. It is appropriate for rating calculations by using distribution coefficients. Extract can have multiple feeds, heater, coolers, and side streams. Here are the examples of columns models for practical applications such as the design and rating of distillation columns and also liquid-liquid extraction column. The next unit operation model is PressureChangers. Pressure changers are used to model pumps and compressors, and for calculating pressure change through pipes and valves. Pumps is used to change the pressure of liquid, while comp is used to change the pressure of gas. Both pump and comp calculate either the power required or produced, or the outlet pressure when the other is given. Pump model is used for pumps and hydraulic turbines, where comp is used for polytropic compressors and turbines, polytropic positive displacement compressors and turbines, and also isentropic compressors and turbines. MCOM, or multi-stage compressor or turbine. MCOM is a model for changing stream pressure across multiple stages with intercoolers between each stage. An aftercooler following the last compression stage is optional. The coolers can have liquid knockout outlet streams. A variety of specification options are available for both the compression and cooling stages. MComp simulates a multi-stage polytropic compressor, polytropic positive displacement compressor, and isentropic compressor and turbines. You can also specify the performance curves for rating pump and compressor. Pump and comp model pressure changes when energy-related information, such as a power requirement, is needed or known. For pressure changes only, use other models such as heater or valve. Valve model calculates the pressure drop or valve coefficient for a control valve. It is used to model multiphase and adiabatic flow in ball, globe, and butterfly valves. Pipe model calculates the pressure drop and heat transfer for a single pipe segment with fittings. It can model a multiphase, one-dimensional, and steady-state and fully developed pipeline flow. Pipeline, or multi-segment pipe. Pipeline calculates the pressure drop and heat transfer in a pipe segment or a pipeline. Pipeline can have any number of segments which represent different pipe geometry. Pipeline assumes the flow is one-dimensional, steady-state, and fully developed. It can perform one- or two-phase calculations and calculates either inlet or outlet pressure when the other is given. Pumps and comps are general model, so they can be used to model any types of pumps and compressors, such as centrifugal or reciprocating. They can be applied to a wide range of equipment size, such as from a small air compressor to an enormous natural gas compressor, as shown in the next slide. This is an example of natural gas compression package, which includes reciprocating compressor driven by the engine. The package offers a wide range of suction and discharge pressures. Further information can be found in the link attached to the picture. Here are some examples of valves commonly used in processing plants. Globe valves. Globe valves are used in the systems where flow control is required and leak tightness is necessary. Gate valve. Gate valves provides good shut-off for fully open or fully closed operation. Butterfly valves. Butterfly valves are used to stop, regulate, and start flow. They are compact and lightweight. Needle valves. Needle valves are similar to glove valves, but it is used to give very accurate control of flow in small diameter piping systems. And the last one is check valve. Check valve prevents backflow in the piping. Further information of valves can be found through this link.